Example 16. If each day your fairy godmother put $1 into a savings account at 8.37% compounded daily, how much would the account be worth when you were 65 years old? Assume a 365-day year. All right, this was example 5A. And when we discussed it the first time around, we decided that this problem needs to be solved using the future value of an annuity. Okay, again, how can you tell? Well, you see the phrase compounded daily. That eliminates simple interest. Okay, your fairy godmother is saving money, so it comes down to how the money is being saved. Is it a one-time deposit or is it a recurring deposit? And if you read the first sentence, it says, if each day your fairy godmother put $1 into your account. Okay, so it is regular deposits of $1 per day. Okay, so that makes this the combination of saving money and it being regular deposits. You're going to use the future value of an annuity formula. Okay, so let's go ahead and write this down. Okay, so here's our formula. All right, so we need to figure out what we're looking for and what the values of our variables are. Okay, so we know, let's see here, we know the interest rate is 0.0837. If you change it to a decimal. The deposits are daily and the interest is compounded daily. Those two things should coincide. So that means M is 365 because you are reminded here to use a 365-day year here. The money is being saved for a total of 65 years. So there's your T value. And now we just need the P and the A. Okay. So when you're doing this type of problem and using this formula, P is the amount of each regular deposit. So P is $1. Okay. So that leaves A, so we must be solving for A. Again, if you reread the problem, it says how much would the account be worth, 65 years later, okay? So you are looking for the account balance down the road. So that is the A value that is unknown, okay? So let's go ahead and plug everything in. All right, so we're going to get 1 times, in parentheses in the numerator, 1 plus 0.0837 divided by 365, okay, raised to the 365 times 65th power, okay. You have to subtract 1, so squeeze that in, and then divide by R over M. Oops. So this is what it's going to look like if you set this guy up, okay. All right, so luckily we are solving for A because that's the simplest variable to solve for when using this formula, okay? So essentially we just have to type everything in, and it's even better because everything in brackets is multiplied by 1, so we can just ignore this and calculate what's inside the brackets because anything times 1 is itself, okay? All right, so let's go and plug and chug, okay? So again, when you're plugging this in, you're going to start in the numerator because it's the more complicated than the denominator, okay? So just type in exactly what you see. You're going to have open parentheses, 1 plus, see if I can get this in better lighting. Okay. Okay. Well, hopefully you can see it. 1 plus 0.0837 divided by 365, close parentheses. Exponent's complicated here, so make sure you put it in parentheses if you need to. So 365 times 65, close the parentheses before subtracting 1. And this is going to give you the numerator, okay? And then we need to take that answer and divide by the denominator. So in parentheses, put the denominator. Got to put parentheses or it won't come out correctly. Okay, close the parentheses, okay? Remember, you don't need to, but I mean, of course, you could take that answer and multiply by 1. You'll get the same thing back. So there is your account balance after 65 years. A lot of zeros, which is good news for you. And now we all want a fairy godmother. Okay, so there's the balance. Okay, so this is going to be in dollars. and we need to round to the nearest cent to state the final answer, okay? So there's 2 cents. We need to look at the number after the 2, so that's a 5. If it's 5, 6, 7, 8, or 9, you need to round up to the next cent. So this is going to be $1,430.03. That's how much is in your account after 65 years. Okay, pretty cool. Next, let's look at example 17. Okay. All right. Tim and Jessica have set up a Texas 529 plan in order to have a oh, okay, I have a typo there. Let me start over. Tim and Jessica have set up a Texas 529 plan in order to have $120,000 in 15 years for their children's college education. How much should be paid semi-annually into an account paying 6.8% compounded semi-annually to reach their goal? So let's scratch out this unneeded A. All right, so this was example, let's see where, example 5E, okay? So back when we looked at it, then we decided this is future value of an annuity, okay? Let's write down the formula and then we'll talk about why. All right, so Tim and Jessica are saving for their children's education. They want to save a total of $120,000 in 15 years. And so they're paying into a savings account. So that's your first clue. We're saving money in a savings account. You've got the phrase compounded semi-annually, so that eliminates simple interest. So you've got to look at how often they're making deposits, okay? So the question is, how much should be paid semi-annually? Okay, when you see that phrase, they are making payments semi-annually into their savings account. That means twice a year. Okay, so it's regular deposits. That makes it future value of an annuity. Okay, all right, so let's write down our variables here. Okay, we know the interest rate, their savings account has a 6.8% interest rate, so that's 0.068. Okay, we know the M value. Okay, the interest is compounded semi-annually. That coincides with semi-annual deposits. So M is going to be 2, twice a year. The time, they're going to save for a total of 15 years. Okay, so let's look at the P and the A. Okay, so remember when you're doing this kind of problem, P is the amount of each deposit that they make. That's what we're trying to figure out. How much should be paid semi-annually into the account? Okay, so how much is each payment? We don't know. We're trying to figure that out. A is the accumulated amount. What balance do you want to have after 15 years? They want to have $120,000. Okay, so that's the value of all your variables. Okay, so let's go ahead and plug everything in. So we're going to get this. Just leave P as P because we don't know what it is. All right, so this is how you set up the problem, okay? All right, so goal is to solve for P, okay? So on the left side, you have 120,000, and then you've got equals P times all of this stuff in brackets, okay? Everything in brackets is just a number. You could punch it into the calculator, and you're going to get some probably ugly decimal, I'm guessing. So let's figure out what this number in brackets is, okay? So let's take our calculator here. Let's see if that makes it better. Not really. Okay. Let's see here. What do we got? I'm just trying to get it to show up for you. Okay. So what do we got? We've got, start with the numerator, open parentheses, 1 plus 0.068 divided by 2 raised to the 2 times 15 power, close parentheses, subtract 1, okay? This is going to give us the numerator, okay? So there you go, okay? Now we want to take that quantity and hit the division key, put your denominator in parentheses so that it comes out correctly, okay? So this is the number that we're multiplying P by, okay? So I'm going to go ahead and write that out. Okay, so it's going to be P times 50.78138026. Okay, so the left side is still 120,000. Okay, so now if we want to isolate P, all we have to do is divide both sides by this number. Okay, so P is multiplied by this. To undo that, you're going to divide it off. Okay, so we're going to take both sides and divide by this number. Got to write tiny over here. Got to carry all the digits. Okay, so on the right side, these guys will cancel. Okay, so go ahead and plug into your calculator here and see what we're going to get. We can just do 120,000 divided by the previous answer. Okay, and we'll get that answer. Okay, so let's write this down. So 2,363. And if we round, we're going to get 7 cents. Okay, because you look at this digit, it's a 0, so you want to, you can just keep this the same. Okay, so this tells us that Tim and Jessica need to save $2,363.07 every 6 months or semi-annually in order to have a total of $120,000 for their children's education in 15 years.